All right, so in this example, you are dealing with magnesium being added to silver nitrate. And the first thing you want to be able to do is to tell what type of reaction this is. Is this a double replacement? Is this a single replacement? Is it a combustion reaction? And knowing what type of elements these are or compounds will give that away. This is an element. This is a compound, meaning two or more different elements, which tells you this is a single replacement reaction. Whenever you have a single replacement reaction, you have to look at this thing called an activity series. On the back of your periodic tables, I told you that it would be a good idea to write down that this activity series is only used for single replacement reactions only. Single replacement reactions only. What you want to do is you need to examine this activity series to see if this reaction will even occur. Here's magnesium, here's silver. This is magnesium, this is silver. Right now, silver is a compound with nitrate. But magnesium wants to replace silver in this compound, and the only way that will happen is if magnesium is a more active metal or a more reactive metal than silver. So because magnesium is higher on this scale than silver is, this reaction will happen. What I like to do with single replacement reactions is I like to break up all of my compounds into its ions. So silver has a +1 charge. By itself, you need to memorize that. It's a Zach element. Nitrate has a -1 charge. This is on the back of your periodic tables under your polyatomic ion list. And magnesium is in group 2. It is an alkaline earth metal, and it has a 2+ charge. Now, in a single replacement reaction, the positive ion, also known as the cation, they switch places. So what happens is when they switch places, silver becomes the single element, so single replacement, it becomes the single element, and then the compound that's formed is formed between magnesium and nitrate. If I'm thinking back to the naming and formulas unit, I might remember that I'm going to need 2 nitrates for every magnesium ion for my balanced equation. Not balanced equation, excuse me, for my proper ionic compound formula. So this is what my formula looks like when magnesium and nitrate get together. So if I were to ask you just to predict the products, this is what I'm looking for inside of this box. These are the products you would predict that would form between these two reactants. Now, I can ask you even more about states of matter, and states of matter come with understanding a little bit more about the nature of the elements. Like silver is a metal, so I can say that this is a solid. Magnesium nitrate is something I have to look up on the back of my periodic table on the solubility rules. Your solubility rules tell you that nitrates are all soluble. There are no common exceptions to that rule. Therefore, magnesium nitrate is aqueous. This is not the balanced equation for magnesium being added to silver nitrate. If you wanted to balance the equation, you could go back and do that using the rules that we learned for balancing equations. I'll just give you the quick answer if you're interested. It looks like I need a 2 coefficient here, and I need a 2 coefficient here. And that's it.